From STEEM to STEEM, Part 2. To prevent a goal displacement, making mathematics a goal instead of a means. Thien Trung, Ho Chi Minh City University of Education, Vietnam. Alan Tup, mathacademy.net, Denmark. With only 4 types of numbers, unit math is easy. Algebra, in Arabic, means to reunite. With only 4 types of numbers, there are only 4 ways to unite, and 5 ways to split. Addition and multiplication, unite changing and constant, unit numbers. Subtraction and division, split into changing and constant, unit numbers. Integration and power, unite changing and constant, pair numbers. Differentiation and root or logarithm, split into changing and constant, pair numbers. Here, root means factor finding, and logarithm means factor counting. But, in math, numbers have no units. So math differs, outside and inside, the no-unit math greenhouse. Outside. 1 plus 1 depends on the units. 1 week plus 1 day, is 8 days. 1 meter plus 1 meter, is 2 meter. 1 kilometer plus 1 millimeter, is 1 kilometer. $10 plus 10%, is $11. Inside. 1 plus 1 is 2, always. So no unit math is mathematism, true inside, but seldom outside its greenhouse. Science statements must be valid, so mathematism is not a science. We ask, the 3 grand theories. How to make easy math hard? Philosophy says, choose essence over existence. Psychology says, choose Vygotsky over Piaget. Sociology says, choose means over goal. How to make hard math easy? All 3 says, choose the opposite. So, to make hard math easy, we choose. In philosophy, existence over essence. That is, existentialism over Platonism. In psychology, Piaget over Vygotsky. That is, radical constructivism over social constructivism. In sociology, goal over means. That is, agency over structure. The goal of math education is that to master math, or to master many. All say, the goal is to master math, to later master many. But math is hard. Why not first master many, to later master math? So we ask. What math may grow from children's innate mastery of many, as developed before school? How do children master many? We ask a 3-year-old, how old next time? The answer is 4, showing 4 fingers. But, reacting strongly to 4 fingers, held together 2 by 2. That is not 4, that is 2 twos. So, children see what exists outside, bundles of twos, in space, and 2 of them, in time. They use, not line numbers, but bundle numbers with units. And, they use a full number language sentence, as in the word language, with a subject, a verb, and a predicate, that is 2 twos. A basic child activity is to trade. A basic trade question is, 4 threes, is how many 5s? 4 times 3, is 4 threes, but we need 5s. Now, if, from 4 threes, we pull away 5, a calculation predicts that, 4 times 3, pull away 5, gives 7. Now, if, from 4 threes, we push away 5s, a calculation predicts that, 4 times 3, push away 5s, gives 2. Sum. Now, if, from 4 threes, we pull away 2 5s, a calculation predicts that, 4 times 3, pull away 2 times 5, gives 2. So the answer is, 4 threes, is 2 5s and 2. Or with bundle units. A total of 4 bundle 0, 3s, is 2 bundle 2, 5s. Economics, sharing what we each produce. To survive, humans must labor, work, and act, aren't? So, the human condition is, eat, produce, and create. Production equals productivity, times persons, times hours. Productivity is what a person produces per hour. Productivity increases with new technology, numbers, calculators, etc. Productivity increases when we produce what we master best. But at what exchange per number? From STEM, over STEAM to STEM. From hard to easy, if rooting mathematics in economics. Math is hard, 2 plus 3 times 4 is 20, for too many. Teach STEM. It motivates reasons to learn math, before applying it. Oops, math is still hard, 2 plus 3 times 4 is 20, still. Teach STEAM to sugarcoat a desire for learning it, before applying it. Oops, math is still hard, 2 plus 3 times 4 is 20, still. Teach STEEM to master many, to later master math, not the other way around. Yes, now math makes sense. 2 plus 3 times 4 is 2 ones, plus 3 fours, or 3 bundle 2 fours, or 1 bundle 4 tens, or 14. Let us master mathematics, through its original root, economics. Let us respect, that math is a natural science, about many. Productivity Step 01, a bundle counting sequence. Stocking in threes, or in twos, I have, or get, a total of 10 is, 3 bundle 1, threes, or 5 bundle 0, twos. With the stock size, threes, stocking in space, bundling gives, 10 is, 3 bundle 1, threes. Stocking in time, I use a bundle counting sequence. 0 bundle 1, 0 bundle 2, 0 bundle 3, or 1 bundle 0, etc., until 3 bundled 1. Likewise, if the stock size is 2, or 5, or 10. Including the bundle when counting, we get a bundling counting table. So, instead of counting 1, 2, 3, etc., we now count 0 bundle 1, 0 bundle 2, etc., 0 bundle 9, 0 bundle 10, 1 bundle 0. And 9 bundle 8, 9 bundle 9, 9 bundle 10, 10 bundle 0, 1 bundle of bundle, 0 bundle, 0. And 1 bundle of bundle 0 bundle 1, 1 bundle of bundle 0 bundle 2, etc. Children love to make number icons of cars, dolls, spoons, sticks. Changing 4 ones to 1 fours will create a 4 icon with 4 sticks. An icon contains as many sticks as it represents, if written less sloppy. Once created, icons become units when counting in bundles, as children do. Divide and multiply and subtract and add, may be demodeled as icons, also. From 9, push away 4s, we write 9 over 4, iconizing a broom, called division. 2 times lift the 4s to a stack, we write 2 cross 4, iconizing a lift, called multiplication. From 9, pull away 2 4s to find unbundled, we write 9, pull away 2 times 4, iconizing a rope, called subtraction. Uniting next to, or on top, we write B plus C, iconizing the 2 directions, called addition. Calculations predict counting results. Here, we bundle count a total of 9, in twos. 9, bundled in twos, leaves 1 unbundled. We stack the 4 bundles as, 4 times 2. With 1 unbundled placed on top. From 9, 9 over 2 times, we push away 2s. From 9, we pull away 4 2s, leaving 1. So, the calculator prediction is T equals 9 equals 4 bundle 1, 2s. The unbundled is placed on top. Separated by a decimal point, 4.1, 2s, or counted in bundles as 1 equals 1 over 2, times 2, giving 4.5 bundles, 2s, or counting what is missing in a full bundle, 5 bundles less 1, 2s. So, inside decimals, fractions, and negatives, are rooted in, how we outside see the unbundled. Bundle counting fingers in threes. Counting 10 with overload, normal, or with underload, we get. The total is, 2 bundle 4, or 3 bundle 1, or 4 bundle less 2. But, 3 bundles are 1 bundle of bundles. So, a total of 9 is, 1 bundle, threes. And, 10 is 1 bundle, and 0 bundles, and 1, threes. Or short, 10 is 101, threes. So, with units as bundles, and bundle of bundles, we do not need the place value system. Flexible bundle numbers ease operations, when using overloads, and underloads. Counting in tens, 74 is 7 bundle 4, which is 6 bundle 14, which is 8 bundle less 6. With addition, 74 plus 18 is 7 bundle 4, plus 1 bundle 8, which is 8 bundle 12, with overload, and 9 bundle 2 without, thus giving 92. Likewise with subtraction, and multiplication. With counting or division, we write 33 bundle 7 with an overload as 28 bundle 56, that counted in sevens gives 4 bundle 8, or 48. So, with overloads and underloads, we don't need to carry or borrow. Recounting from icons to tens, asking 6 times 7 is what, we meet algebra, in a bundle square. With no 10 button on a calculator, we cannot use the recount formula. But multiplication gives the result directly. 6 sevens is 6 times 7, which is 42, which is 4.2, tens, only without units, and without a decimal point. On a pegboard, or a squared paper, we may set up a 10 by 10 square, with 6 and 7 on the sides, written with underloads as bundle less 4, and as bundle less 3. We see that the 6 by 7 block is left when, from the b times b block, we pull away a 3 times b block, and a 4 times b block, and then add the 4 times 3 block that was pulled away twice. Again, we see that 6 sevens recounts as 4 bundle 2 tens. Also we see that minus times minus must be plus, since it is pulled away twice. Writing the numbers over each other, we see that the result comes from multiplying, first down, then across. Also, we see the FOIL rule, first, outside, inside, and last. Productivity step 07, shift units, please. Recounting creates a recount formula. Shift unit, from 1s to 2s, 8 is, how many 2s? Bundle counting shows, that 8 is 4 2s, or 4 times 2. This is predicted by a calculation. 8, pull away 2s, is 4, or, 8, over 2, is 4. So, the recount result is, 8 over 2, times 2. With unspecified numbers, we get a recount formula. T is, T over B, times B, or T contains T, over B, B's. This is also called a proportionality formula, used to solve equations, and used all over science. It shifts units, in linearity, in local linearity, and in trigonometry. As well as in economics, where dollar is, dollar over kilogram, times kilogram, which is, price times kilogram. And in STEM, where meter is, meter over second, times second, which is, speed times seconds. The recount formula solves equations. Asking, how many 2s in 8, gives the equation, u times 2 equals 8. That is solved by recounting 8 in 2s. U times 2 equals 8, but 8 equals 8 over 2 times 2. So, u equals 8 over 2. Thus, solving equations means, moving to opposite side, with opposite calculation sign. This method works all over. Plus to minus, multiplication to division, exponent to root, and base to logarithm. Recounting in 2 units creates a pair number, as 4 kilograms per $5. We change units, simply by recounting in the pair number. 12 kilograms is, 12 over 4, times 4 kilograms, that is equals, 12 over 4, times $5, or $15. With like units, pair numbers become fractions. $4 per $5, is 4 per 5. Recounting the sides in a block, halved by its diagonal, gives trigonometry, and pi. In Greek, geometry means to earth measure. The earth may be divided in triangles, that may be divided in right triangles, that may be seen as a block, halved by its diagonal. This half block has 3 sides, the base, b, the height, h, and the cut, c. They are connected with the angle by pair number formulas, recounting the sides, pairwise. H is, h over c, times c, which is sine angle, times c. H is, h over b, times b, which is tangent angle, times b. B is, b over c, times c, which is cosine angle, times c. H times h, plus b times b, is c times c, so the diagonal square adds, the bundle squares. Tangent angle is h over b, which is the change of y, over the change of x, or the rise over the run, which is the diagonal gradient. A circle contains very many small half blocks. This provides a tangent formula for the number pi as, n times the tangent of 180 over n, for n large. Once counted and recounted, totals may be added, but next to, or on top. Adding 4 5s and 2 3s next to as 8s, means adding areas, as in integral calculus. Adding them on top as 5s, means changing units, by recounting. Reversing next to addition. If T1 as 2 3s, together with T2, add next to as 4 7s, then what is T2? The recount formula predicts the result. From the 4 sevens, we pull away the 2 threes, before recounting in fours. Reversed next to addition finds differences, or changes, in areas, so it is called differential calculus, or change calculus. Here subtraction precedes division, which is natural, as reversed integration, where multiplication precedes addition. Pair numbers add as areas, called integral calculus. We ask, 2 kilograms at $3 per kilogram, plus 4 kilograms at $5 per kilogram, is 6 kilograms at how many $ per kilogram? We see that unit numbers add directly. But that pair numbers must be multiplied to unit numbers, to be added. And, since multiplication creates areas, pair numbers add as areas, under the pair number curve. So, in integration, multiplication comes before addition. Therefore, pair numbers and fractions are not numbers, but operators, needing numbers to become numbers. Here, the pair number curve is piecewise constant. It becomes locally constant by interchanging epsilon and delta. Then the sums are replaced by integrals. There are 8 competencies inside the no-unit greenhouse, but only 2 competencies outside the greenhouse. To master many, first you bundle count and recount, then you add. Unit math brings back brains that are excluded to special education from the no-unit math greenhouse. There is a YouTube workshop in flexible bundle numbers to develop the child's innate mastery of many. To master many, we bundle count and recount before we add. So, unit math represents a paradigm shift from line numbers without units inside a greenhouse to bundle numbers with units outside. Conclusion. Yes, core mathematics may be learned through its historic root, economics, describing how humans trade, what each produces. Asking, how many did I produce, will root counting, predicted by division, iconizing a broom pushing away bundles, to be stacked by a multiplication lift, to be pulled away by a subtraction rope, to look for unbundled singles, to be added on top, thus rooting decimals, fractions, and negative numbers. Recounting in a new unit creates a recount formula, used to solve equations, and to change units, as in most STEM formulas. Recounting in 2 units gives pair numbers, becoming fractions, with like units. Mutually recounting sides in a box, halved by its diagonal, gives trigonometry. Uniting stacks on top, or next to, roots proportionality, or calculus. Therefore, why make mathematics hard, when, with units, it is easy, and meaningful? Stop the goal displacement. Mastering many is the goal, and math is but a means. A final question. In the United Nations 17 Sustainable Development Goals, number 4 is about quality education. Should ethical quality education force children to enter inside a no-unit math greenhouse that slowly strangles their innate number language by using line numbers to learn no-unit addition that folds outside? Where children's innate mastery of many just waits to be developed by flexible bundle numbers available at their fingertips. The communicative turn in language education. Before 1970, foreign language was taught as an example of its grammar. Then a reaction came, with the communicative turn. Halliday said, a functional approach to language means investigating how language is used, trying to find out what are the purposes that language serves for us. Likewise, Widow Sun adopts a communicative approach to the teaching of language, allowing more students to learn a language through its use for communication about outside things and actions. So, the question is, can mathematics also have its communicative turn? Theoretical background. From 2018. Mastering many by counting and recounting, before adding on top and next to. Journal. From 2020. Demodeling numbers, operations, and equations, from inside to outside understanding. Journal. From 2021. Flexible bundle numbers develop the child's innate mastery of many. YouTube workshop video. From 2022. Bundles bring back brains from unethical special education. Journal.